Um, Today I am going to speak about opportunities and challenges with the design of high-strength steel in from R&D point of view. I represent R&D sector and I would like to introduce my institution before proceeding to the presentation. CSIR-Structural Engineering Research Center is one of the CSIR laboratories exclusively for the structural engineering research, and we have the facilities and expertise for the analysis, testing and design of structures and structural components. We have 10 different laboratories exclusively work for in various aspects of structural engineering, and these are the expertise. So, we work on 4 thrust areas. One is the special and multifunctional structures, structural health monitoring, disaster management and advanced materials for sustainable structures. I would like to show some of the technologies that is readily available for transfer to the industry. One is on prefab technology for housing. We have come out with one prefab technology made of double skin sandwich panels with some lightweight concrete, and we have developed the various components, one-way slab, two-way slab, some jointing mechanism to make a building like this. So, it is a prefabricated one and all the connections are it can be dismantled and erected at the other place. And the main feature of this technology is it can provide us up to G+3 stories. It provides us safe shelter in zone 5 regions. Next comes the lightweight slab. It is a extremely lightweight coal form decking slab with a unique profile and some lightweight concrete topping, and which is more economical than the conventional decking slabs. And next comes the one patented technology. We have developed a fuse element for a steel moment resisting frame that connects the beam to column in addition to the connection. So, this fuse element, it acts as a fuse during the earthquake. It dissipates large amount of elastic energy, and it tries to avoid the deformation coming over the beam and the column. So, in case of any post earthquake, the damage of the fuse, it can be replaced at within 20 or 30 minutes of time, which is going to be more economical. So, coming to high strength steel, the steel with the grades 420 to 700 MPa, it is termed as a high strength steel, and all the grades above 700 MPa, it is termed as the advanced high strength steel. Yes, due to the higher yield strength, it has got a higher mechanical performance, and it results in very lightweight structures and reduced cross section. So, all these things bring economy into the structure, and also it provides a sustainable solution. So, if we see the global high strength steel market by application, the automotive industry, it takes most part of the curve, and so high strength steel is largely used in the automotive industry. And next comes the building and construction, where 17% of the global high strength steel market is used by the construction industry, and it is expected that by 2030 and Asia Pacific region is going to dominate the market with a percentage of 8.8% share. And even though it is obviously it is high strength steel is more expensive than the conventional strength steel, but the price increase is less than the rate at which the strength increases. So, there is a guideline that the 460 grade is 30% stronger, but only 10 to 15% more expensive than 355 grade steel. And also 690 is nearly 50% stronger, but only 30% more expensive than the 355 grade steel. So, coming to the opportunities for high strength steel in construction, it can be used in the buildings as a stocky columns. So, in the with the low and medium slenderness ratio, because as the height increases, the vertical forces coming in the column and the foundation increases. So, replacing this, so high strength steel can resist the higher axial loads with less carbon footprint. That is replacing the 355 grade with 460 grade steel. 15 to 25% weight reduction can be achieved beyond the 4 to 7 stories, and it can be used in the as a HSS reinforcing bars in cores, floors and foundations. It can act as a lateral stability systems, as a transfer beams and bracings. It also finds its application in the light gauge steel framing sector, and we use the C-section profiles as in wall panels. So, by adopting the 550 grade, it is possible to reduce the thickness of the C-section profile from 1.6 mm to 0.7 mm. And also this can be used in the steel, high strength steel decking profiles can be used in the long span structures. This can act as a permanent formwork for the concrete, and it also helps to avoid the the conventional formwork that occupies more space and provides the traffic congestion, and this is another application. It is also it is applicable for long span structures, especially for airports, station stadia. It can be used as a tension members, bottom and top chord members in a truss. It can act as a bracing member in trusses. And one case study in it's a building is Stiga Sports Arena, Sweden. The span of the building is 52 meter, and they have used the 355 grade for braces and 700 grade for bottom tension cord and 420 for compression cord. And another living example is a Friends Arena roof truss, Stockholm. The span of the building is 162 meter, and they have used 690 grade for bottom cord and 900 grade for outer diagonals. So because of this, they are able to achieve 17% weight reduction over 355 grade steel, and also 14.5% cost reduction is achieved in this project. Next application is bridges. So in bridges, reducing the structural dead weight of the bridge is a major concern, and compared to the fabrication cost, and it is going to incur more cost. So it has application, it can be used in truss bridges, in pylons and cables, and it can be used as a hybrid bridge girders. In hybrid bridge girders, the top flanges can be made with the high strength steel, and the web can be made with the web steel. So because of this hybrid girder, we will be able to achieve it is going to be 13% cheaper than the homogeneous HSS sections. And one living example is this railway bridge in Europe, and it has a weight reduction by 30% with the use of high strength steel. Next comes the connections. We are able to get high strength bolts and moment end plate connections. We are able to reduce the thickness of the end plate, and so this reduces the connection cost also. And other applications, temporary structures, steel sheet piles and high strength steel bearing piles, and it can be used as a tension rods. In multi-story frame structures, it can be all the dissipative members can be made with the mild steel, and the elastic members can be made with the high strength, non-dissipative elastic members can be made with the high strength steel. Because of this, we are able, it is going to be more reliable and cost efficient. So these are the successful engineering applications of high strength steel over the years from 1990 to 2020, starting from the grades 400 to 900. So the challenges in designing with high strength steel is obviously here the demarcation between the yield and ultimate strength is very less. So this is going to give a there is no visible yield plateau when we go beyond the 500 MPa, and this is going to bring new challenges in the design of steel structure, HSS structures, in terms of static strength, buckling behavior, seismic response and fatigue response. So whatever the design requires, design rules available, it requires modification to take advantage of the properties of high strength steel. When we talk about the standards, IS 800, it speaks only for the yield strength less than 450 MPa, and all the other European codes.
Closing remarks, please.
Yes, now we have the second generation Euro codes that are trying to address for the high strength steel. So, so I am trying to conclude that, that we need a separate design code for high strength steel to take the advantage of the properties of that. So we have to start the research on high strength steel. So some of these are some of the research studies says that whatever the design rules applicable for conventional steel may not be applicable to high strength steel, because we are able to get more conservative, because the existing codes give more conservative predictions for that. So the challenge we are facing is getting the material for our study. So at this point I would like to invite the industry to collaborate with us for the development of design guidelines that is beneficial for the practitioners. Thank you.